This is Algebra 2 at Trig, Unit 1C, Point 2a. We're simplifying square roots. What we want to do is look in here and write down our factors, our perfect squares, actually. So 1 times 1 is 1, 2 times 2 is 2, 3 times 3 is 9. So what are your other perfect squares? When we say 4 squared, we come up with the number 16. So 16 is considered a perfect square. When we're taking square roots, we want to take square roots of 16, of 9, of 4. 5 squared is 25. Now you probably know many others, at least up through 10. So go ahead, pause the video, write out your other factors, like 6 squared, and 7 squared, and 8 squared, and try several of those, then come back and check your work. Now we have 36 for 6 squared. 7 squared would be 49. Those should be ones you should be pretty familiar with. Probably had to learn those to get out of 4th or 5th grade. Got a few other ones that might start to stretch you a little bit. So we worked our way all the way up to 20. 20 times 20 is 400. Now the numbers like 144, you need to know that the square root of 144 is 12. Maybe even the square root of 196 is 14. A blank is a value beneath the radical sign, a radicand. That's what we call the value that's underneath a radical. Inside the square root would be called a radicand. You cannot take a square root of a negative number. So radicals, specifically here square roots, they have properties. And one of the properties is the product property. When you're multiplying two terms together, you could separate them into two radicals, or vice versa. If you have two radicals that are separated, they're both the same, what's called an index, they're both square roots. We can write it as one radical, or one square root. So here, we get 9 times 2. That would be an obvious way to get 18. You might even say 6 times 3. That would be another way to get 18. What if I use a different set of factors? Will I get a different answer? The answer should be no. There's only one answer. So we all know what the square root of 9 is. It's in our chart. Square root of 9 is 3. You can't take the square root of the 2, so you leave it inside the radical. So you have 3 root 2. You look over here at this other one, and you go, wait a minute, I can't take the square root of 6. That's not up in the chart, the square root of 3. but 6 is able to be broken down. So 6 breaks down into 2 times 3. The 3, of course, slides down. Now you're looking for pairs of the same number. You have a pair of the same number, you're going to bring it out in front. If you want to call that pair 9, because it's 3 times 3, you call it 9, and the square root of 9 is 3, so you pull it out in front. Either way you want to think about that. A quotient, a fraction, taking a radical. If you have a big radical, big square root of a fraction, you can break it into 2 smaller ones. So over here, we can break this into the square root of 2 and the square root of 25. The best thing we could do is to get this down to square root of 2 over 5. It's a requirement not to have the denominator have a radical in it. That's not fully simplified. Just a proper way of leaving it, and it's not with a radical in the denominator. To simplify a radical, a square root expression is simplified if the following conditions are true. No perfect squares or square factors other than 1 are in the radicand. So nothing can be broken down. And no radical appear in the denominator of the fraction. So that's what would make this simplified. So we're going to simplify these radicals. $75 is a square root of 25 times 3. Well, the square root of 25, that's part of our chart, so that's 5 root 3. Now we look at letter B. I go, okay, I can't break that down. You know, I don't know the square root of 7. I don't know the square root of 35. So maybe I need to multiply those two together. No, don't make it bigger. Then you got to break it down. It's already broken down. Can you break it down more? 7 times 7 times 5. 35 is 7 times 5. So yeah, that breaks down great. The 35 gets broken down into 7 times 5. You now have a pair of 7s. So that's 7 square root 5. With our fraction, we can break this into 2 smaller fractions. So the square root of 100 over the square root of 169, well, that's 10 over 13. And then our last one here, we have square root of 11 over square root of 144. That's the square root of 11 over 12. Now you see that now to finish up, what if it doesn't simplify completely? What if the bottom isn't a perfect square? What if the bottom had the radical in it that you couldn't break down? What do we do? Then now we're going to rationalize the denominator. The process of eliminating a radical from an expression's denominator is called rationalizing the denominator. If the denominator just has a monomial, just a square root of something. If you just have a square root of something, hopefully it's simplified, then you can multiply it by itself. And a radical times itself is going to be the number inside. So the square root of 2 times the square root of 2 is 2. Square root of 8 times the square root of 8 is 8. So let's come down and try that. So here we have the square root of 2 over the square root of 15. Neither of those can be broken down effectively. So what I need to do is get rid of the denominator, or at least the radical from the denominator. So that means I'm going to do the square root of 15 over the square root of 15. That's the square root of 30 over 15. Because root 15 times root 15 gives you 15. It's really 225. The square root of 225 is 15, but you can go right to the 15. The other option we have here is working with a binomial. If you're working with a binomial, you have to break down or multiply, maybe that's a better term, multiply by the conjugate. And when you multiply by the conjugate, you multiply the 4 times both terms, and on the bottom you have to FOIL that. So you get 25, you get 5 root 2, you get negative 5 root 2, and notice what happens here. You get a negative root 2 times root 2. You can call that 4 if you want. You can also just call that square root, or you can call that 2 if you want. You can call that square root of 4 if you want. For now at least. So we have 20 plus 4 root 2. What happens to these middle terms? They're going to cross out. That's the whole point of a conjugate. Now you have 25 minus 2, which is 23. Nothing simplifies. So we leave it like that. For the next one, we got a couple different choices. We can break that up as the square root of 9 over the square root of 8. Now we know the square root of 9 is 3. We know the square root of 8 is 4 times 2. So we can actually simplify this down a little bit. The square root of 4 is 2 with the 2 that's left inside. Now we have 3, 2 root 2, and to rationalize the denominator, we're going to simplify or to multiply by a root 2. So this gives us 3 root 2 because you multiply. And then root 2 and root 2 is 2. So that's 2 times 2, which is a total of 4. Now, back here, let's take another quick back here a second. I jumped into this conjugate. Remember, the signs are different. That crosses out the middle terms every time. That really came from the notes that I kind of leaped over because I wanted to show you this one. The conjugate of a plus root b is a minus the square root of b. Those are conjugates of each other. It's like the difference of two squares. When you multiply them together, the middle terms cross out. An example of that was right here. The middle terms crossed out. a plus the square root of b would be the conjugate of a plus. So their conjugates together, which makes those conjugates together. These are not considered conjugates because they're just the same term. So the expression a plus root b and a minus root b are called conjugates. And when you multiply conjugates together, we always get a rational number. So 2 more to work through. So we're going to multiply by the conjugate. This is a binomial, 7 minus the square root of 5. So we're going to multiply by 7 plus the square root of 5. Whatever you do to the bottom, you also have to do to the top. We would distribute this negative 6 through to get negative 42 and minus 6 root 5. Then this bottom one, because it's 2 binomials, we're going to FOIL it. 49, 7 root 5, negative 7 root 5, negative 5 and 5. If you want to say it right now, it's just 5 and 5. They're both in radicals, so it's square root of 25. Nothing we can do to the top. But the bottom, notice, this is what makes it a conjugate. The middle terms will cross out. We got a positive 7 root 5 and a negative 7 root 5. They cross each other out. We have a 49 minus square root of 25, which is 5. So that gives us negative 42 minus 6 root 5 over 44. Do you recognize anything with those 3 numbers? They're all even. So one way to think about it is if you factor out a 2 and you factor out a 2, the 2's can reduce. You got to be able to reduce it out of both sets of your binomial on top. So your final answer is negative 21 minus 3 root 5 over 22. You can factor out a 3 if you wish, but there's nothing to reduce it with, so we don't do that. All right, last one. Here's a binomial. So if we're going to rationalize the denominator, we have to multiply by the conjugate. Whatever you do at the bottom, you have to also do at the top. Now notice I didn't do anything with 3 minus square root of 7. I don't care about the top. I only care about the bottom of the fraction. So I'm looking for the conjugate at the bottom of the fraction. I have to go through and FOIL this out because it's 2 binomials. Seven times 10, they're both in radicals, so I can call that 70. That doesn't break down at all because it's 2 times 5 and 7. Here we get 2 and 2 is 4, negative 2 root 10, positive 2 root 10, and negative square root. If you want to call that 100, you can. Notice that the middles cross out. That's the whole point. The top, there's actually nothing you can do with this top. 6 minus 6 root 10 plus 2 root 7 minus the square root of 70. There's nothing you can do with that. The bottom becomes 4 minus 10, which is negative 6. Square root of 100 is 10. So if we want to do something, sometimes people talk about not having a negative in the denominator. So we could run that negative through the top, and you would no longer have it in the denominator. It's a little bit more proper to have it down there. All right, want, there's not a 2 in here, so I could factor a 2 out of some of those, but I can't factor a 2 out of this one. So there's nothing I can do. So we're all set. Rationalizing the denominator.